Great. So my name's Ed Robinson. I work at a company called Reevoo. I'm on a team that we call DevOps, but I'm sort of a developer, but also have to deal with everyone's problems as well. So that's fun. I've also done a whole bunch of different open source stuff, and that's kind of one of the great things about where I work is that we're really encouraged to kind of contribute to lots of different open source projects. We've done recently stuff like a FluentD plugin for extracting systemd logs, and I've been working quite a bit on Træfɪk, and we're open sourcing a lot of our actual sort of production apps as well under sort of AGPL and stuff like that. So we're really excited about kind of coding in the open quite a lot for the stuff we're doing for our clients, and also contributing back to the community with stuff like Træfɪk and Kubernetes and all that stuff. So I guess really, in terms of background, what we do in the company is we build things like this for our clients. We basically go out to people who've bought things and ask them for their opinions and reviews and stuff. So this is like a widget that we're putting on Mazda's website where someone's bragging about how cool their car is. What I do is, in my team is we kind of focus on building a really great experience for the developers so they can get shit done, basically. This is a thingy that we built that's basically a Chrome plugin that adds some extra functionality to GitHub. So when our CI systems finish building and we've got an image pushed up to the registry, they can go on here and press this button. It's got a little picture of a squirrel on it, and so all our developers call it touching the squirrel, which sounds pretty rude. And we do stuff like notifying them on Slack that everything's gone okay. This guy decided it was cool to deploy at 9:30 in the morning. I probably wasn't even up, so I'm glad it all went okay. So I'm kind of trying to talk about microservices and containers and how you make them all work together in production, and kind of some of the things that are maybe have been missing in the past, and hopefully there's stuff like Træfɪk now that's a great solution. So microservices are really great for developers. They solve a lot of problems that certainly we as a company have in a lot of our legacy code that we're still supporting now. We've got many, well, I think we've got 3 or 4 what we'd describe as monolithic applications. So it's kind of a megalithic architecture. It's pretty gross. But about 1.5 years ago, we kind of made the decision that going forward, we would be extracting microservices and building new things as microservices as well. Kind of the whole pattern really encourages you to build loosely coupled code. It encourages you to think about building to interfaces and testing those interfaces so you can ensure your different services work well together. It means that you can be quite robust to change. With a big monolithic application, it can be that a developer comes in, maybe they're fairly new to the project, they haven't read all 500,000 lines of code, they change something over here and everything over here blows up. Microservices give you some kind of, protection against that. So it's really great for developers. And the other great thing about it is it encourages people to use the right tools for the task at hand. You're not encouraged all the time to say, well, we're already using this database because we chose it in the past. We can say, we've got this new task to do. We're building a new service for it. We're going to choose the best database or the best programming language or whatever to build that thing. So that's really great. There are some real problems, though, with microservices as well. Stuff that's really hard to kind of pin down. The big one for me, I think, is while the people building the application have a good idea of what's going on, the stuff they're dealing with is smaller, they understand their problems better. The other people in the business who are not, heads down writing code have a completely different conception of what the application is. I don't think it maps very well to the business expectations at all. Someone comes over to you and says, oh, the API is broken. And you go, which one? We've got 50 now. So I think that's a problem. And also because you've got lots of small things, you get a lack of consistency. It can be really hard to make sure that you're doing things like security correctly in all of the different places now. And maybe you end up re-implementing similar concerns again and again, stuff like authentication, things like that. So then thinking about why containers are a good fit for microservices, I've kind of stolen this word encapsulation. It's kind of a object-oriented programming thing. But I think the general idea of bundling up your application with its dependencies, shipping an artifact that has everything that your program needs to run is really great. It helps to solve a whole class of problems with, well, it works on my machine, but there's a different version of, whatever library on production and everything explodes. So we get that dev prod parity and stuff that it seems like you get for free, but maybe you don't. Flexibility and efficiency. You're able to pack your workloads onto the servers and hopefully save money and stuff, which is nice. I've been thinking about minimal services. This is something I shipped the other week. Basically, we had a requirement that, we want to set up a web server and put some files up there for some client to download and stuff. So in 6 lines of code, we've got this horrific bash script that runs every so many seconds and does some stuff with the AWS CLI to pull some files off S3. So I think containers give us the opportunity to go ahead and ship really, really small things, ship the minimum viable product, even if it is a little bit shit. You can totally go out there and build this, and then if it turns out to be, this big important kind of service, you can build on that. But it lets you ship things really fast, make mistakes, move on, stuff like that. So I wouldn't say these are problems with containers, but these are things that you end up wanting when you move to containers. When you've got the kind of traditional architecture of using configuration management and spinning up all these VMs, maybe on a cloud provider or provisioning servers and stuff, you kind of don't want to do scheduling or service discovery or operations. You end up giving everything a name, and these problems aren't really apparent because you're wasting your resources and you don't want to be dynamically scheduling your software, because scheduling means, SSHing into a machine, running a big bash script, all that kind of stuff. So there are additional things you have to do to get service discovery, operations, scheduling stuff right. The cool thing is, though, we have got a great ecosystem of tools now. Whoa! Lovely. There are 2 really awesome container runtimes that we've got to choose for doing the kind of work we do, putting web apps into production. Docker is really good. We're looking at Rocket as well. They both seem great, so there's stuff to choose from. Am I standing on that? I won't do that anymore. Dear, oh dear. So there's Kubernetes, there's Mesos, Docker Swarm is a thing too. We've got these great tools for orchestration, for service discovery. There's stuff like console, etcd, and Kubernetes kind of builds in the whole story about service discovery, so it's not really a separate concern for you if you're using Kubernetes. So when we come to deploying our microservices to production, we end up with a lot of containers and whatnot in our infrastructure, and hopefully we've got Mesos or Docker Swarm or Kubernetes scheduling them to the right server, making sure that all of our containers keep running and managing our resources for us. But we come to wanting to let traffic in from the internet. We want to set up different rules and paths and stuff. So, we can serve up our API and maybe a back office app and stuff like that. So we end up sticking a reverse proxy in the middle and setting up some rules. In the past, it kind of meant config file from hell. This is not really a demo per se, but it's a file I pulled off of one of our servers this morning. It's actually from Varnish, which is a front-end sort of caching system, but we're really using it as a reverse proxy here. So we've got lots of sections like this. This is just a description about connecting up to a backend service here, Mark1, reevoocloud.com. And I think there's 8 of these. And then there's some other services that have been split off from this big monolithic app that we're running here, and a bunch of other stuff, and it just keeps going, and who knows what all this is. And pretty soon it gets horrific, 465 lines of code long. I really hope that we're using some kind of configuration management tool to sort this out, but I'm not actually sure. And so we're deploying this kind of configuration here. So when we do that, it's really important that all of those servers exist with that kind of, the DNS set up properly and all of these different moving parts. So this is definitely something from our legacy architecture that is not using containers and is not using an orchestration system. And I think even with some of the tools that are out there to kind of look at that and automatically write your config files for you, I wouldn't really trust how that would work. So we ended up taking a look around at a lot of different options, looking at HA proxy or Nginx or stuff like that, and templates for config files and stuff. We ended up finding Træfɪk, which is a reverse proxy, but what's really good about it is we've got an extra line on our diagram here, perhaps hundreds if it keeps doing that. But what Træfɪk can do is it can listen to the API provided by our service discovery mechanism or the orchestration system or whatever, and it can know about where the containers are running, and it can set up its configuration itself in a really robust and tested way. So there's lots of features. The main one for me is it supports all of the things that you'd want to run your containers, as far as I know. If it doesn't yet, then let us know, and we'll add support for it. It supports Docker on its own, Docker Swarm, Mesos with the Mesos DNS thingy, Mesos and Marathon, Kubernetes, Console, etcd, Zookeeper, BoltDB, files, don't use those. And it's got a bunch of other stuff. It's reasonably fast. Last time we did a benchmark, it gives you about 85% of the raw performance of Nginx. So for all of the flexibility and stuff it gives you, it's pretty decently fast, and we're working on making it faster as well. There's a bunch of middleware that you can plug in. You can do stuff like circuit breakers. So if one of your backends stops working, maybe it's got too much load or something, you can cut requests off to it for a certain period of time, wait for it to recover, and then put it back in the pool. We can retry requests by routing them to other backends, do rate limiting, basic auth, stuff like that. It does WebSockets, it does HTTP2, has SSL support, has built-in stuff for Let's Encrypt as well. So yes, there's loads of features. So hopefully everything will explode and you can have a good laugh at my demo. So this demo is based off a tutorial I wrote for our documentation website, which is about launching containers into a Kubernetes cluster and then using Traefik to load balance them. What I've done is set up Kubernetes inside Minikube, which a couple of other people have talked about already. So we've got an empty cluster right here. Here's the Kubernetes dashboard. I've already deployed Træfɪk to Kubernetes. We've got a nice UI here that shows us what's being load balanced by Træfɪk right now. Actually, the only rule we've got in Træfɪk is one to load balance its own UI there. So I'm going to rush through this because we haven't got that much time. But first of all, we're going to launch some websites. These are just containers with Nginx in and some brilliant web design I did a bit earlier. So we're going to launch some containers onto some pods onto the Kubernetes cluster. We won't see anything in Træfɪk there yet, but fingers crossed. Cool, they're running there. And we've got some kind of cheesy websites set up, one for Cheddar, Stilton, Wensleydale. It's a funny story, really. Basically, the guys who started the Træfɪk project and have done most of the work are from France, and they give every release a kind of French cheese code name. So it's just a bit of banter, really, with, the best cheese in the world. Great. So the next thing we need to do is give Kubernetes some services. So we've got a way of routing the traffic to the different pods in Kubernetes. So I'll have a quick look at that file for you. We're just using label selectors here to pick out the different cheese apps and the different tasks. We've got Cheddar one and Wensleydale one here, Stilton one. And then the magic bit happens when we pick up the cheese ingress. Kubernetes defines a resource called an ingress, which is responsible for all the stuff to do with this kind of load balancing and letting traffic into your cluster. On other platforms like Docker or Mesos or whatever, there are slightly different kind of ways that the orchestration system lets traffic know what's going on. On Docker, you'll have to apply certain labels to your containers when you launch them, different stuff like that. But basically, we're just routing here some different host names, the Stilton one, the Cheddar one, and the Wensleydale one, to actually just go back to these back-end services here. So if everything works and we set that up on the cluster, I should be able to go into a web browser here and type in maybe stilton.local. And wow, Stilton. And just to prove that it really does work, there's Wensleydale as well. Cool. The demo is a bit longer, but it really does work. And I think I'm going to finish the presentation rather than the demo because it's a bit more interesting. So I've just got some slides here about ways that we might want to deploy Træfɪk to production. Here's basically what I was doing just now on my own machine, this kind of developer setup. I've got a VM here, which is running Docker inside, and I just launch a Træfɪk container and bind port 80 to the IP that we're running Docker on. And so we can go into our web browser and look at our awesome kitten app. So that's kind of the basic thing. I guess you might use it if you're doing, like a little side project and you just want to have a single machine running Docker, put a load balancer in front of it and launch some containers on there, and, for your own machine just to try stuff out. If you've got a cloud provider like AWS, something like that, they probably give you some kind of mechanism for getting set up with a load balancer. In AWS, the Elastic Load Balancer is quite nice in that you can set it up and have it span your public and private networks. So you can load balance traffic into the private network and assign it IPs on the outside. So that's really the simplest possible way. You can just go ahead and launch a number of replicas of traffic into your cluster and the traffic will just get in there and that'll be set up. That's what we do in production right now, mainly because it's really simple. If you've got a different kind of situation where you're not using a cloud provider, or you want something that's a bit more performant and hasn't got these extra layers of stuff, you probably look at launching like dedicated machines, or maybe part of your cluster having Traefik nodes running on there, or it could even be every single machine in your cluster. You could just run a Traefik node on there, and then you could do round-robin DNS, or look at maybe a CDN provider or something to route your traffic into your cluster. They're kind of ideas I had about how you might end up putting traffic into production in kind of a resilient way. The final thing I'm going to look at is some of the kind of patterns of architecture that you can create when sort of looking at load balancing and microservices together. So the first thing I'm thinking about here is if you've got an API, and at the beginning I spoke about kind of this mismatch between what the business's idea of an API is. It's like, we're company XYZ, we have our awesome API, but the developers think we've got a product service, an order service, and a billing service. So in Træfik, you can go ahead and make some different rules on the paths and bring that all into a cohesive API that's load balanced under a particular domain name, and then route the traffic to the right containers running on your system. Maybe these have like internal dependencies between them and stuff, but you've got like a clean way of exposing that traffic. Another kind of pattern is if you're thinking about maybe refactoring this kind of monolithic Stonehenge app here, and maybe you want to take the cool sort of kitten bit out of that, do a bit of refactoring. You can put your kittens in a container. I think that's a cardboard box, but I'm sure it is a container. And then you could just write a rule that just takes this API kittens path from the monolith domain and routes that through to your new container, your nicely refactored microservice, and route the traffic for everything else back into your monolithic app that's not sort of been touched yet. The other really nice pattern that I found is if you're building front-end apps, maybe they're mobile apps, or maybe you've got like some kind of front-end JavaScript frameworky thing. I don't know, there's awesome stuff nowadays. And you might want to have one container that contains all of your front-end assets for your application, and then you might want to build yourself a kind of back-end that routes all of your traffic through to your microservices architecture, but gives you kind of an API that's really impedance matched with what you want for your application. So maybe you can make one API call per screen, stuff like that. So that's another case where you might want to take two different microservices that maybe you deploy separately, that live in different containers, built with different tool chains. Maybe you're using Python for your back end and some JavaScript thingy for building your front end. You can deploy those separately in containers, but then bring your configuration back together and route your traffic nicely. It's over, but it would be awesome if you could check Træfik out on GitHub. We've got 4,440 stars, but we want more because stars. We've got a website, there's documentation and stuff on there. If you want to use Træfik, there's 446 people on Slack. It's a really active community. Everyone helps everyone else out. So it's quite new. Some people have had some problems, but I think a lot of questions have been answered really quickly on Slack, and people come together to help that out. My company's hiring. If you know Ruby, you could come and work with me. You might not want to, who knows. And I've got a Twitter thing and GitHub.